Good afternoon, everyone, and welcome to NASA's Kennedy Space Center in Florida, where we are gathered for the launch of the SpaceX CRS-6 flight. It will be launching from Cape Canaveral Air Force Station tomorrow at 4:33 p.m. Eastern Time, and we're here today for the pre-launch news conference for the mission. And I'm pleased to be joined by a panel who will fill us in on all the aspects of the mission. To my left is Dan Hartman, the Deputy International Space Station Program Manager from the Johnson Space Center in Houston. Hans Königsmann, Vice President of Mission Assurance for SpaceX. And Dave Kraft, our Launch Weather Officer from the 45th Weather Squadron at Cape Canaveral Air Force Station. And we'll begin with comments, and then we'll be happy to take your questions. Dan?
All right, thank you very much, and good afternoon, everybody. It's great to be back at KSC for another resupply mission to the International Space Station. SpaceX 6, the Dragon, will be carrying about 2,000 kilograms of total pressurized cargo mass for us. About 85 or 850 kilograms of that will be for our research work that we'll be doing over the next 35, 36 days that we have the birth mission attached to the station. The rest is cargo resupplies and maintenance gear that we need to keep and maintain the station. And then on return, we'll be bringing back about 500 kilograms of research. So a big pressurized research mission for us, and I know you've heard some additional information on the research that we'll be doing in the previous panels. With the launch tomorrow, Samantha will capture Dragon around 6 a.m. on Wednesday. The hatch will be open the following day. And like I said, we anticipate a 35, 36-day mission with an unberthing and return on May 21st. So a lot of work for the crew to do on board the ISS during this time period. As far as station, we've done the pre-launch checkout of the SSRMS and our vehicle systems. We had our IMMT, mission management team, on Thursday, and we're not working any outstanding issues on the space station. So we're ready to go capture and bring it into the Node 2 Nadir port. I was talking to Hans just a little bit ago. The late cargo processing that we'll do is underway. It's still in our hands. We'll be turning that over to SpaceX for loading into the Dragon within the next hour, and then they'll proceed with that onto the launch. So far, everything is going very, very smoothly there as far as the gear that we're getting ready to go fly. Part of the cargo that's going up as well is in support of our ISS reconfiguration that we've talked about in the past. This is where we're trying to put two docking ports on the International Space Station, one on Node 2 Forward and one on Node 2 Zenith. We had 3 very successful EVAs in the February-March time period that laid all the cable out on the truss, put up some antennas, laid wire to the Node 2 Forward port in support of the International Docking Adapter, which will come up on SpaceX 7. So when that comes up on SpaceX 7, the space station is ready to receive it today. And so no further EVAs or wiring needs to be done to accommodate the docking port. So that's a great 3 EVAs that set us up into that position. I mentioned that we laid the wires and the antennas on the outside of the trusses, P3 and S3. Our communication boxes that actually talk to the antennas will be coming up later this year, and we'll install those into the lab. And we're still on track by the end of the year to be able to support or have the systems on board to allow docking of one of the commercial crew vehicles. And so we want to make sure we get that done ahead of us. We can do troubleshoot any issues we may find in efforts to be ready for when they're ready. So that'd be great. Our consumables on board are in good shape. You know, we took a hit in the last October time period, and we're still catching up. You know, we're around 4.5 months of consumables for food and water of that kind of nature. We like to maintain 6, and so by the end of, I'll say, November, we hope to be back up to that 6-month reserve level that we just like to accommodate on the ISS. The 1-year crew, Scott and Mikhail, they're in full swing. They've settled into the space station. They began their 1-year science missions that will take them for the long journey. And the rest of the crew, they're doing great. They're very, very excited of getting SpaceX 6 up here tomorrow. Additional upcoming vehicle traffic to the station, it will be very, very busy for us over the next few months. With SpaceX 6, and then we have Progress 59 that will arrive in late April, April 28th. We have 41S on docks on May 13th with 43S launch on May 27th. We have another SpaceX 7 launch in the middle of June, June 19th. We've been working with our Japanese counterparts on trying to nail down when the next HTV mission will be, HTV 5. Right now it is August 18th, and that looks like it's holding pretty firm. Another SpaceX launch in mid-September, and then we'll get back with our orbital flights out of KSC in the November time period. So we're staying extremely busy and look forward to the launch tomorrow. If we have a weather or any kind of issue tomorrow, we do have the backup day on the 14th. Any backup days beyond that, we're going to have to go back and work with not only our science community, SpaceX, and the range, and so we'll work those after we find out what's going on or if we have an issue tomorrow. And with that, I'll turn it over to Hans.
Thank you. I'd like, actually, before I forget it, to thank NASA for the opportunity to deliver cargo to the ISS. This is the midterm mission, actually. Actually, after that mission is midterm, right? But it's been a great program, and I really enjoyed it very much. SpaceX is really proud to serve the ISS. Also like to thank the 45th Space Wing and the FAA certifying and supporting the launch all the time. And then I thought I continue with the least important part, and just want to tell you that we're trying to land on the autonomous spaceship, which has been named Just Read the Instructions. I'm going to go a little bit into detail how we do this. Basically, what happens is and again, this is the least important one. I'm going to follow up with the most important one after that. After the stage separation, we're going to flip the stage around 180 degrees. We're going to perform a so-called boost back burn. That boost back burn will keep the first stage from falling too far. It keeps it a little bit closer, and basically will target the drone ship. And then after the boost back burn, which lasts about half a minute roughly, we're going to have another shutdown, and we deploy the fins. These grid fins that you can see on the vehicle, they're folded in right now. They're folded during ascent, and then they come out after the boost back burn. After that, we will coast. We will reach about 125 kilometers and then come back into the atmosphere. That's the time when we do an entry burn. The entry burn is literally tapping the brake a little bit so it doesn't get too hot during the entry. That entry burn is it's fairly short. It's about 10-15 seconds, and it happens about 7 minutes into the flight. And then as the stage comes further down, it decelerates through the re-entry. There's going to be a landing burn. That landing burn is on the single last engine, basically then. And halfway through the landing burn, you see the well, I'm not sure you see it, but the landing legs will deploy, and shortly thereafter we will touch down on Just Read the Instructions. So, getting this out of the way, I can talk about the main and the primary mission here. The primary mission is, as Dan mentioned, to bring up 2,000 kilograms, roughly 2 tons of scientific and supplies to the station. That's what the second stage does. The second stage continues the ascent after it separates from the first stage. It will burn for roughly almost 10 minutes, 9 minutes 40 seconds is shut down. And these times vary a little bit. Depends on how well the engine runs, actually the weight we know pretty well, but it's mostly, there's small variations here and there, so it could be a couple of seconds longer or shorter. It will insert Dragon into a 200 by 360 kilometer orbit. It's the ISS inclination, of course, and it will deploy Dragon 35 seconds after shutdown. We should be able to see shutdown from the ground. Shutdown from the ground and actually Dragon deploy from the ground. Dragon will then deploy the solar arrays within the next 2 minutes. And that's about the end of the mission, at least for Falcon 9. Dragon, of course, continues. Will take about 38 hours to the station, where it begins to climb on the arbor and get grappled by the astronaut, and will be berthed to the station. there. It will stay up there for 35 days, which is the longest we've ever done, I believe. Pretty sure, actually. And then will be unberthed and will depart from the ISS and land in the Pacific Ocean, basically in our front yard, where we pick it up and bring the return cargo to the harbor. Return cargo is, if I remember correctly, about 1,300 kilograms of really important science results that have to be powered the entire time, kept cool and kept chilled the entire time, and we supply this in Dragon all the way from the ISS onto the boat at this point in time. And that's all I had. Dave?
All right. Hey, good afternoon. I'm Dave Kraft, the Launch Weather Officer for the 45th Space Wing. I'd like to start out with just framing the meteorological situation for everyone. It'll be better for you to understand the situation that we're looking at and the challenges that we're facing over the next couple of days. Typically, in April, here in Central Florida and along the Space Coast, it's one of the driest months relative to the rest of the year here. And the past couple of days, that is not the case. So it's not typical really for the majority of the upcoming week. And we're looking at more of a summertime situation. And summertime meaning that it's a wetter situation. And we're looking at sea breeze activity, sea breeze formation every day, late morning to early afternoon, and then moving west of the spaceport, and then collisions of the sea breezes in the afternoon. And then, so the challenges that we're looking at are the really thick cloud and ample cloud blow off from some of these thunderstorms that would be inland or in close proximity of the spaceport, and then drifting back toward us by the afternoon. So we're looking at ample cloud threat mainly in the next couple of days. Thick cloud, which is thick cloud 4,500 feet thick or greater, and the altitude of concern is at the 0 degrees Celsius height, and if it spans that height, and the minus 20 degrees Celsius height. So if I could draw your attention to the satellite imagery, this is today's visual satellite that you see right now. It'll briefly in a couple seconds it'll rotate through to an infrared, but that's what's firing up actually right now along the Space Coast. Now, looking at the southeastern U.S., those color, this is an infrared shot, by the way. The colors and the dark, those bright reds and yellows, that's a lot of very strong high altitude tops thunderstorm activity stretching along a frontal boundary that's east-west oriented north of us. Now, typically in April, these fronts still make their way down through us. But like I said, it's not a typical week in April for us. And if you see this east-west orientated front, all the activity is concentrated along that boundary to the north of us in northern Florida. So what it is, it's actually allowing south of that boundary, that's the surface boundary, south of that boundary is tropical moisture, tropical weather like conditions that we're experiencing. So more of a summertime situation. So if I could get into the forecast. We're looking at mostly cloudy skies, 7 miles visibility with isolated shower chance for the launch day, with thunderstorms again inland, with the blow off of the ambles approaching us by the T0. And probability launch weather constraint is 40%, and again the primary concern will be ample cloud and thick cloud layer. Winds will be out of the southeast, about 12 to peaking to 17 miles per hour. Next slide. If we need a 24-hour delay, similar conditions, still mostly cloudy skies. I'd like to point out more of a southerly direction for the winds, and that actually allows the sea breeze to hang a little closer during the afternoon and not progress westward away from us as much as it normally would these past couple of days. So we're actually, another primary concern for the 24-hour delay would be the cumulus cloud. We'll add that in because we could have some more activity closer in on the 24-hour delay. But still, nevertheless, a 40% chance probability of violating. And then for recovery landing forecast, a couple hundred miles off Jacksonville for the first stage, we're looking at a 70% cloud cover, so cloudy skies. If you keep in mind that satellite imagery before, it's closer to that surface boundary, so it's going to be cloudy, some showers in the area. Sea state will be 4 to 6 feet, and it's looking fairly favorable to land, just not the greatest viewing. But there will be some isolated showers in the vicinity for the recovery, and we're looking forward to that. So that's all I have.
Okay, Dave, thank you. We will take your questions now. If you're in the room, please let us know if you have a question by raising your hand. We have folks with microphones, and they'll bring them around. We ask you to wait for the microphone and state your name and affiliation and to whom you're addressing the question. And we'll start off with Marcia Dunn.
Marcia Dunn, Associated Press for Mr. Koenigsmann. This is your third attempt to land. I mean, is there anything different about this third try, and do you see your odds as being better to achieve this since you've got the other two behind you?
Yeah, so if you recall, on the first one, we ran out of control authority on the fins, fluid basically. We fixed that on the second one. On the second one, we didn't have a drone ship there. The weather was terrible on the second attempt, and it looks right now like the weather is significantly better. 4 to 6 feet of swell is nothing. We did also upgrade the drone ship so it can keep the position better. So we are more we can tolerate a higher wind and swell level than previously. And I guess together, the improvements on the vehicle on the first stage and the improvements on the drone ship itself, I would up my probability to 75% at this point in time, maybe 80.
Irene.
Thanks. For Dan, with the addition of the 3 more cargo flights for SpaceX, does that have a corresponding increase in the contract value from 1.6 to roughly $2 billion?
I don't know this. It would have, obviously an upward in the contract value. I'm not quite sure of the total budget or total money allocated for those 3 missions, though.
Is it roughly the same as the 12 for 1.6?
Yeah, Hans might. I'm sure there was a typical inflation for the out years, considering when these vehicles are flying. But it was escalation, probably on top of what we had. Mm-hmm.
Jim.
Jim Siegel. I'm with the Celebration News and the Spaceflight Insider. Question for Dan. You mentioned the consumables earlier, hoping to get up to 6 months or so of supplies. I'm interested in whether anything new or different is going up with this group of supplies. Any new foods? Any new whatevers?
On this particular one, we're flying about a month's worth of food. So it's not the ones that push us over the edge, I'll say. That is going to be HTV-5, where we've kind of a new thing we're doing. We're flying 30, I'll say rather large bags of water. That'll get our water consumables significantly improved, as well as a lot of food. And I don't have the specific numbers for you. And then Orb 4, which will follow in November, again, will most likely carry some water for us and a significant amount of food as well. Some of the Dragon missions we kind of try to use for some of the dedicated science that really needs the capability to bring powered late load research hardware up as well as return. And so we're a little bit picky of making sure we give that to the research community first, and then we'll pick up some of the slack on consumables with the other vehicles. That's kind of been our plan.
We'll take a question here in the front row and then come over to Ken, and then we'll go back over here.
Stuart Money, Interspace.net. My question is for Hans. Has there been any change in the landing profile, or did you learn anything from the Discover attempt, even though the drone ship wasn't there? Have you tweaked it in some way since the Discover launch?
I believe that if the drone ship would have been there, it would have been a good landing. and I don't think we made any changes following that. So from that perspective, it was literally just missing the ship. Now, having said that, we haven't tested the last couple of seconds, and so that, of course, is important. Yeah, but there was no significant change on the vehicle side between the last flight and between the last attempt to land and this attempt to land. Actually, independently, I want to point something out. When Dan says SpaceX 6 and I say CRS-6, we mean the same thing. It's just different.
Ken.
Hi, Ken Kramer for America Space and Universe Today. A question for Dan, please. With the loss of Orb 3, can you say was there any impact on science? Is the science that's ongoing now impacted any way by the loss of Orb 3? And with Orb 4 launching on an Atlas, how confident are you that you'll actually be able to launch that in November? Sure. Because it is a different vehicle. I know you had to do a lot of new work to make sure that everything would work out well.
We did lose some science on Orb 3. Nanoracks deployers. I was actually up Wallops looking at a lot of the hardware that came back, and so we adjusted our SpaceX 5 manifest to fly as much, backfill as much research as we could. Again, balancing it with the consumables discussion. But some of the specifics on Orb 3, I'd have to get, I know NanoRacks had a large complement of payloads on there that they'll be looking to refly with the CubeSats. And then as far as Orb 4 on Atlas, if you think about the Cygnus side of things and the way Orbital in the past has integrated onto the bus of Atlas, they're very, very familiar with that. They've done satellites with that. So as far as an overall integration issue of the Cygnus onto the Atlas, that seems to be going rather smooth. And so I have not heard of any showstoppers that would get us out of that November time period. And then we also have to play with, and that's not play with, but we have the constraint of when an HTV flies, because they use the same prox system. You need to get HTV down. We need to convert that over to the Orb system, and that takes a little bit, an indefinite amount of time. So by the time HTV flies, then it has the mission duration, and then you need to do this handover to support Orbital. November basically lines up for them.
Jason.
Jason Ryan for SpaceflightInsider.com. This one's for Hans. Hans, you guys encountered a little bit of problem with your helium bottles in I believe, the first stage of the Falcon 9. Can you describe a little bit about what you encountered there and what changes you made, if any, or noted that involved these helium bottles?
Yeah, I think the right term is an abundance of caution. We didn't have anything fail or anything leak on the vehicle. It's very important. We didn't find anything on the vehicle side either, but we had some test articles and some rejected hardware that we looked at and became concerned and wanted to investigate if we had similar conditions on the vehicle. We didn't see anything. Now, CRS-6 was actually at a position where this was relatively easy. That's why the schedule for CRS-6 was not affected. So from that perspective, it was fairly transparent.
James.
Oh, thank you. James Dane, Florida Today. Hans, I was wondering if you could describe a little bit the upcoming upgrades to Falcon 9 and how soon does that happen? How many more flights before you implement those?
Yeah. So there's upgrades coming on mostly engine thrust. What we do right now is we run the engines basically with a lot of margin and basically not 100% power. It's probably equivalent if you would say we're running at 80%, and what we do is we go to full performance. So we call this actually also full performance. These upgrades folding in one of the next vehicles. I'm always looking at the next two, and I believe it is in 4 vehicles then from today. So that will bring our payload a little bit up and allow us to do better return to land, first stage landings, and partial landings on payloads that are more demanding primarily. I don't think you see any significant change on the outside of the vehicle.
Hi, Enzo Vito, NASA Social, Embry Riddle Prescott. This question's for Dr. Königsmann. In January, the Associate Administrator Gerstenmaier said NASA would direct SpaceX to redesign the Dragon to carry water to the ISS in response to the Orbital Sciences mishap. What were those redesigns, if any?
Yeah, and that was you want to try? Yeah, we're from the space station program. We're the cargo guys. So we looked at. In fact, we performed. We have some bags, big bags that typically fit in, I'll say, the shuttle mid-deck lockers. Of the past, that's kind of what we sized them for, and flew them actually sometimes on those to protect them. We couldn't find. We were looking for nooks and crannies, I'll say, within the SpaceX Dragon, and still trying to protect the resupply, cold stowage for the research folks, for the payload folks, and so we didn't want to impact that. So what we had to do is redesign slightly, tweak our bag design a little bit, and we have since performed that and are able to carry water on SpaceX. We've elected not to do that so far, but we put that capability in place in case we needed it. And so it's just a design feature that we have to carry water on Dragon. SpaceX really didn't have to make any modifications to their vehicle to accommodate that. It was on our side. Yeah.
Christian Kiske with NASA Social. Mr. Hartman, continuing on with the water, my 12-year-old son is particularly amused by the recycling of the water on the space station. And so as a consumable, how much is lost with the recycling, and how much would that, how long would that water last?
Yeah. It could be indefinitely, right? So, we actually turn our urine into drinking water. We collect sweat from the crew members as they exercise. Your air conditioning systems at home have condensate, and so we collect all that water, put it through our water processor on orbit. And right now, I think we're about 80% recollection, right? So we lose, I'll say another way to look at it, you lose 20%. We dispose of that in a variety of forms, primarily brine, which is a very thick, unfiltered substance, I'll say. But 80% is good. We also have the Sabatier system on board, where we can use the byproduct of our carbon dioxide scrubber, CO2, plus some hydrogen, and we can create additional water from that event as well. So overall, big picture between the two, that part of our main regen system in Sabatier, we're roughly about 80%, and we're constantly trying to push that, because as you know, a gallon of water weighs 8 pounds, and it's expensive to launch a lot of mass to orbit, and so the better we can do on getting that percentage higher, the better we'll all be. That is one of the key drivers for our environmental control team as they look for kind of their roadmap to exploration, is how can we get that up to 85–90%, and we're working on some techniques now.
Rusty Meadows, NASA Social. This question's for Hans. Can you talk about the implications of a successful Falcon landing and what that means for future missions?
The implications of a successful first-stage landing. Well, first it would be an epic launch landing party, I guess. We would need to look at the stage and evaluate on what do we need to do to refly this particular stage, and so for us it's a really valuable object to work towards reusability and to take whatever action we have to take to get the stage back in a state that we can then refly within a short time. So in the long term, obviously, if you're able to refly your first stage, you need to establish how many times can you refly it. Is it 20 times? Is it 40 times, 50 times? Where's the limit? What do you have to exchange if you fly more than 50 times? And you get basically into your operation completely changes, in my opinion. You get into a maintenance operation where it's more like an airplane type operation, yeah. And honestly, from my perspective, I look at risk. I actually like getting the stage back because that is the stage I know, and it has it has proven itself. Yeah, so there's some benefit in terms of reliability. You're not always getting to a new car every time you drive to work, right? So I think the implications are huge, and of course in the long term this might change completely how we approach transportation to space.
Jason?
Jason Ryan for Spaceflight Insider again. Real quick for Hans, Dragon is supposed to be partially reusable. Have any components from prior missions flown on or are being scheduled to fly on upcoming flights of Dragon?
In details only, I would say, and I don't think I have the full list here, but not a full Dragon in a way that this Dragon. But it is certainly something that we work towards. It's not the spaceflight itself that uses up Dragon. It's actually more the water landing that does that. Seawater is just not very good for that. You need to protect, and it takes a lot of effort to protect something against seawater corrosion. We learned a lot over the last couple Dragons, basically how to do this, and we are also taking the next step on Dragon reusability in the long run, so that we are able to reuse Dragons.
But Hans, we've worked with the teams, right? There are numerous components that refly on Dragon today and will so in the future. We work with SpaceX. Our engineering teams work with SpaceX to make sure it has useful life back in it. That the margins are still all there. But reusability is acceptable when the hardware performs, and we need to see that kind of verification certification. Once we see it, we haven't had any objections to that going down that path.
Charlie Wood, NASA Social. A lot of the experiments we've heard about today have to do with studying and mitigating the effects of microgravity and zero gravity, and which are obviously problematic for long-term missions, including deep space missions. So my question is a zero gravity environment assumed for a mission to Mars, or is artificial gravity a possibility?
I have not heard of very many studies going on for artificial gravity on the way to Mars. Certainly the effects of the human body and zero-G effects is what we have been studying. The fluid shifts experiments that are going on with the one-year crew, the intracranial pressure and the buildup of the, pressure around the eye and the effects of vision. So everything that I know of has been toward the zero-G effect. I'm not aware of any large studies on defeating that.
Courtney Peterson, NASA Social. On Friday, Elon Musk tweeted 2 pictures of the Dragon being prepared, and he said, "Points if you notice what's new." Now, I could only notice the logo was new, but could you maybe give us some insight? The logo itself, he just tweeted pictures and said, "Points if you can find what's new." And I was just wondering what was new.
The logo changed from the last to this one, so it looks a little bit sleeker, a little bit more modern, I guess, more in line with the Falcon 9 logos.
So it was just the logo that
It's
changed?
just the logo.
Got it.
Looks nicer now.
Ken.
Ken Kramer, America's Space and Universe today for Hans and Dan probably too. I'm wondering about the instantaneous launch window. If you were not doing this flyback, could the launch window be more than just momentary? The other thing about it is this Dragon's carrying about 700 pounds less than the other one. So I'm wondering also from that standpoint why you cannot, since that's pretty significant, why you can't have a longer launch window than instantaneous. Thank you.
So you're right. It's actually instantaneous is to some extent an optimization, because you are optimizing that you hit the right plane by the time you actually do the orbit insertion. You could be off a couple seconds, and what you do is you then have to fix your inclination, and that is expensive. So in other words, if you do launch a couple seconds later, a couple seconds earlier, you could pay this in propellant, primarily actually on the Dragon side. That's why it doesn't help you too much on the landing at all. The landing has no impact, in my opinion, here. And from our perspective, from the launch team perspective, whether you launch at an exact moment or 5 seconds earlier or 5 seconds later, doesn't matter. It's this whole, you get into the whole setup and the long countdown, and at the end of it, you're on a second, basically. Whether 5 seconds longer doesn't help you to solve any problems. And so from our perspective, it's basically automatic, hands-off. This vehicle will launch right on the second. That's optimal for propellant. You could, yes, we had cases where we need collision avoidance timing a second here or there, but it's really just a second.
And to go along with that, a lot of it is driven by our payloads, right? They have, they're being processed in, here at KSC, they're being turned over onto the Dragon. They want to get to orbit and, begin immediate, processing of their research on orbit. And so we at times tend to drive how quick we want Dragon to get to the ISS berth, open the hatch, and get the research out. So that tends to drag it. As far as the 700 pounds, probably you know that we don't have anything flying in the trunk on this flight, and that's probably that would be the majority of the makeup. We had a payload that was manifested for the trunk. It ran into some testing, some integration issues, and so we had an option. And the way that payload would have been installed on orbit would have been completely ground control robotically. So we would have pulled it out of the cargo, out of the trunk of the SpaceX. We would have handed it off to the big arm. It was actually going to go over to the GMEF, and so we would have handed it off to the GMEF arm. All this is orchestrated, choreographed on the ground with ground robotics, and then they would have put it in place on the exposed facility on the GMEF. So that cost us 0 crew time when we had this payload in the cargo bay. We actually had an option to launch the IDA, the International Docket Adapter. We had time to accelerate it and get it on SpaceX 6. Hans's team could have changed the flight support equipment that could have done that. We could have made the G&C system work. But when we looked at installing the IDA, it actually takes an EVA during the berth mission to install it. So you have to then use the time for the EVA, which if it's just a single EVA can be 80 to 100 hours of crew time just to prep the suits, prep the airlock, get the tools ready, get out the door and perform the task. So we looked at the 80 to 100 hours of EVA time it took to go outside versus the mission requirements that we had specifically for the payloads during this time period, and we could not find the room to go suck up 80 hours and take that out of the payload utilization time. So it was purely that kind of trade. Yeah, we wish the first payload would have been there. We could have accelerated IDA, but we elected to protect the research that's flying on SpaceX 6. We'll fly IDA on 7, and we'll pick up this payload on a subsequent trunk once it gets through some integration and testing. And there will be slots available for it.
Irene?
Irene Klotz with Reuters. Hans, could you maybe just go through a little bit about what the plan would be for the Falcon first stage, assuming it does land, where it would go, and what would be the time frame to take it apart, and would you try and then fly it from New Mexico? And then unrelated, if you could maybe give us a little overview of where things stand for the Dragon pad abort test in May.
Yeah, so
Thanks.
on the first stage gets pulled back to Jacksonville Harbor in the next couple of days after landing. It depends a little bit on how the weather is on that and how smooth the landing goes and what shape the vehicle is. So it might take a couple of days more. It's hard to predict really. If it's not a problem at all, I would say 1 or 2 days, but it could be problems, and there will be opportunities then there to look at the vehicle. We will inspect the vehicle there. We will break it over, which means putting it horizontal, which is actually not that easy because it is so tall. You need a crane to pick it up and move it around. And I believe we will bring it to Texas, our test site, for further inspections. Whether we fly it from there or from some other place has not been decided at this point in time. Depends how it looks, what the inspections say, and that we go the next step from there. The second question was pad abort. Pad abort has a tentatively launch date, I believe, on May 2. I don't think it's been confirmed by the range, so that's in work in early May. Now, pad abort is a test vehicle, so it's not a production vehicle. It's been integrated right now. I took a look a couple days ago. It's in great shape. It's a really impressive vehicle. This is a very complex vehicle too. So we do the pad both different than other guys. It's not a solid motor that sits in front of it and just brute force pull this thing out. It's instead it's using actually the same propellant as the vehicle would use later on. That way you don't bring up this weight and throw it away in mid-flight. Yeah, and you get a lot of bang out of your buck too in terms of what you do with the propellant on orbit. So I'm just saying I'll be a little bit cautious. I wouldn't book the flight now, and it might have it might require some flexibility on people trying to watch it.
Marcia.
Marcia Dunn, Associated Press for Mr. Hartman. The Italians are sending up an espresso maker. And I'm wondering, how much interest does NASA have in that in particular? And in general, how important is it going to be for you to try to improve life up there for people as they spend a year and longer in space?
From that aspect, I think it makes, again, I don't know the commercial side of the espresso machine. I think it is going up under our utilization, so it makes me think it is some part of some commercial endeavor. But that part, the psychological support, is very, very important. We do a lot with crew members on orbit to keep them in sync with email, personal phone calls home. They can watch the evening news. Depending on our acquisition of signals, they can have live football games. And so we try to set up once a week two-way parties, video both ways with their family members, or they could have a family member overseas or in some other, not necessarily in Houston. So the psychological support, I think we're going to learn a lot as this unfolds over the next year. But it's, if an espresso machine comes back and we get a lot of great comments from the crew, hey, this is, it's kind of like the ice cream thing, right? When we fly ice cream every now and then. That's just to boost spirits and maybe some rough day, the scoop of ice cream gets them over that hump kind of thing. So I think I don't know specifically about the espresso machine, but those kinds of things I think will be commonplace for us as we continue on with these one-year cruise.
Hi, Val Phillips, Zero G News. We talked briefly about the reusability of Dragon, and that one of the problems is actually the salt water aspect. I mean, living in Cape Canaveral, that corrosion is very much of an issue. How are you trying to resolve that, and are you thinking perhaps of going into maybe on land rather than on water, where perhaps that will be remove that issue and therefore make the capsule more totally reusable?
Yeah, so certainly one problem to solve the seawater corrosion issue is to land on land. That would be a good way to do this. It has other issues. The ocean is just very big, and there's a very low chance to hit anything on the ocean. So that's definitely for the ocean. But you can protect actually hardware against seawater. That is possible, but it's just something that you have to learn and to work into the vehicle. And typically, people that design spacecraft and people that design boats and ships are two different set of people, and you got to find the right people to get this done. But there's different possibilities: coding, paint, surface protection, sacrificial anodes, and all these technologies that help you get corrosion under control. And having worked a couple of years at the Cape, we learned about corrosion, how to purge systems on the pad, and how to make sure that systems live long under these conditions. So.
Go ahead. Christian Kiske with NASA Social. My question is for Mr. Kraft. Regarding the weather tomorrow, how much advance notice do you require, and who makes the call as to whether it's too bad or too good, and how is that determined?
Well, we have an operations center, range weather operations center, over on the Cape Canaveral side, the Cape Canaveral Air Force Station, and there's a team of launch weather officers and we'll be working on console in the early hours of the count, and all the way through recovery of the first stage. But we will actually evaluate from immediately being on console. We'll evaluate the a very detailed set of launch commit criteria, lightning launch commit criteria, that's geared toward natural lightning. It's also geared toward a potential for triggered lightning. So we're evaluating that, and we will actually make a no-go call on the console during that if it's an unsafe situation or it's violating one of those, what we call the LCC rules for lightning. And one thing I neglected to say earlier is that today is a similar day from what we're expecting tomorrow. And actually, at the T0 point today, it was a go condition. So the team relayed to me that it would have been a go. So that 40% chance of violation is probably pretty close, pretty accurate. So we're expecting activity. We're expecting it inland. And we'll be dealing with anvil drifting toward us and some thick cloud.
I prefer to think of it as 60% chance of go.
That sounds good.
I do that too, yeah.
Hope I answered your question.
Yes, thank you.
Good.
James?
Thanks, James, Dean, Florida Today. Dan, obviously these are all quite important, but just you'd referenced kind of still playing catch up after Orb 3. I wondered, and we've talked for a long time about getting the steady cadence as best we can with both providers, and so just wondered if you could maybe kind of state the obvious on how important it is, especially now when you're limited to one provider, a commercial provider, and just the importance of the flight, especially under these circumstances. And Hans, just also wanted to ask, since we're at KSC, if you might be able to update where you're at on 39A and the potential timing of anything Falcon Heavy related.
Yeah, the cadence is important, right? We've kind of said that we need to get into this drumbeat of flights. I think we're all feeling pretty confident in Orbital's ability to get back in gear in the November time period. I think they've done just a tremendous job with how they've gone from October to where they're going to be here shortly. And so does that put additional pucker factor on some of these missions we have flying? The answer is yes. We have some pretty important spares we have on SpaceX 6. We have a couple Cedra beds that Cedra is our carbon dioxide scrubber. So we want to get the 2 new ones up during the dock mission. We want to be able to hopefully find the crew time to replace those and bring those home. We have, we talked about the water processor a little bit earlier, right, in trying to get our 80%. We always like to have a spare on the shelf, and we would have been there, and so there's a couple areas with the Orb 3 loss where we've dipped below that, and so there's a little bit of a catch-up between SpaceX 6 and SpaceX 7 that will get our sparing situation kind of behind us for the critical regenerative ECLS system.
Okay, we have time for one last question in the back of the room.
Okay. I'm Morgan Turner from NASA Social. My question is for Dan and Hans. It's just a bit of a general question about the innovation of Dragon and the other crafts. I know that you were saying that seawater corrosion is a big problem. Is there a way that you actively develop new crafts, or you just build upon the current model and just like build off of its functionality, or do you just completely develop something different on the side while you're using that?
You want to take that? I mean, a good analogy would be your commercial crew vehicle, right? Probably.
Yeah, I mean, but whatever we learned on Dragon folded into a Crew Dragon, clearly, and there's also ongoing improvements on Cargo Dragon itself, and keeping it watertight, water sealed, rather. It's detailed work, and you got to be careful when you make those changes that nothing gets affected by it negatively. So it's just a process we're going through. I don't think it's I wouldn't really call it a huge problem. At the end of the day, the main mission: cargo up, cargo down, power the entire time, and temperature correct, humidity correct, nice environment. We fulfill those 100%. And the reusability is kind of a goal that we want to be pursuing, and particularly Elon, of course, is is really very much into reusability. He sees that as a key to lowering launch costs and space operation costs, basically. And it makes perfect sense if you think about this. So it's a long-term goal that we work towards.
All right. Thank you all very much for coming. We look forward tomorrow to the successful launch of the SpaceX Falcon 9 and Dragon on CRS-6. Our NASA television coverage begins at 3:30 p.m. Eastern Time, as does our launch blog for the launch, which is scheduled to the second at 4:33 and 15 seconds p.m. Eastern Time. Between now and then, please keep track of everything that's happening on social media by following us at NASA and at SpaceX, and also following the hashtags ISS Cargo and ISS. And of course, you can also follow on the web at www.nasa.gov/SpaceX. Thank you again.